Hi, everyone who watching. Today we will discuss briefly why and when organic compounds react, and at first we will start with hydrocarbons. So, as you probably know, we have three or four major groups of hydrocarbons: alkanes, alkenes, alkanes, and aromatic compounds. If you have general formula CnH2n plus 2, CnH2n, CnH2n minus 2, ECnH2n minus 6. This is four main groups, and we have two groups of property. If you're dealing with single bond or aromatic ring, it's substitution. If we have double bond or triple bond, we're dealing with addition. And additionally, as condition for reactions, here we need ultraviolet. Here we need catalyzer, and for alkanes and alkyls, in many cases, no any additional compounds required. Let's see this on examples. For example, we have CH4, methane. At the present ultraviolet, it's form chloromethane and HCl. One chlorine replace one hydrogen. Another case, for example, we're dealing with propane. At the present bromine, under ultraviolet radiation, one of hydrogens replaced by one of bromines, and it's forming for us bromopropane and HBr. So alkanes involve in reaction substitution. Another example, for example, we dealing with hexane. It's a more short formula, and this hexane can react with chlorine and the present ultraviolets, and one of products will be 2,3-chlorohexane. It's one of products. So if we deal with alkanes, it's a reaction of substitution. Alkanes, double bonds. In alkanes, we're dealing with addition, simplest one, most popular one, and most important, economically most important compounds, it's cetane, can react with water and forming products of additions. It's HOH. It's alcohols, ethanol. It's most popular, one of most popular alcohols. Another case, we're dealing with 2-methyl butane and we want to add HCl. Here also reaction of additions. We have two options. Hydrogen can move to left side and hydrogen can move to right side. And according to Markovnikov rules, hydrogen move to place where more hydrogen. So products of addition will be Cl. It's to chloro, to methyl, propane. Another example, alkanes. Alkanes with 2 double bonds. Here we have several options. With, for example, with there are 2. One of these products will be just 1 double bond react like separate double bond. Another options for alkanes, if we have 2 double bonds, dienes, it's products like this. So if you are alkanes, you involve in addition. Alkenes, more rare, but also important, involve in reaction additions. And we have some several options. At first, it can be add chloride, for example, and forming dichloroethane. And we add more chlorine and forming tetrachloroethane. Another reaction for alkanes, it's addition of water at the present mercury salts and water. It's HO. H form for us C carbon bonded with double bond of hydrogen. Okay, so also addition. It's specific addition. Another one, we can, sometimes it's stopped by one stage, HCl react with C2H2 and forming if you know polymers, it's vinyl chloride. It's one of monomers for soft plastics, especially wires as isolations. Sometimes it's windows, frames, and more. And aromatic compounds. Aromatic compounds look like alkanes, 3 double bonds, but react like alkanes, like compounds without no double bonds. But conditions for reaction more soft. No needs to ultraviolets, just require catalyzer, for example, salt of iron chloride, and it's forming and HCl. So many double bonds, but react like no double bonds. Another example, nitration. If we have any groups, its group influence on substitution reactions. For this case, we have special rules. In this case, we dealing with compounds which move in reaction in this position. At the present, nitric acid and sulfuric acid, these compounds can form one of products can be nitrotoluene to nitrotoluene. In other options, benzoic acid, it's popular additives in foods. It's eatable, and salt of this acid also eatable. Also can be nitrated, but in this case reaction moving more slowly, and positions of reactions differ. In our case, we're dealing with three nitrobenzoic acid and water. So what we must memorize? We have alkanes, alkanes, alkenes, and aromatic compounds. Alkanes and aromatic compounds involve in reaction of substitution. Compounds with one or several double bonds or triple bonds involve in reaction additions. And if you know this, you can predict most of reaction. So remember, if you know structure, you can predict property. We not discuss specific reaction for each groups, just in general, if double, triple bond addition, if aromatic or no double, triple bond at all, it's substitution. So for today, it's all. Next lesson, I will discuss reaction at the present oxygen. It's alcohols, acids, fats, proteins, and more. So for today, it's all. Subscribe, share, and don't forget, visit my webinars. Bye.